Intermediate Algebra for Statistics, Linear Inequalities and Systems of Linear Inequalities. Lesson objective: graph a linear inequality in two variables. Lesson objective: we'll begin with the definition. If an inequality in the two variables x and y becomes a true statement when a is substituted for x and b is substituted for y, we say that the order pair a, b satisfies the inequality and call a, b a solution of the inequality. The solution set of an inequality is the set of all solutions of that inequality. We solve the inequality by finding its solution set. Let's do an example. Example 1. Graph y is greater than or equal to 3. Solution. Our first step is to think of the inequality as an equation. To graph y equals 3, that is a horizontal line because the slope is 0 and the y-intercept is 3. Now once we graph y equals 3, we want to shade all the y values that are greater than 3. So here's the graph. This is the equation, y equals 3. The slope is 0 and the y-intercept is 3. And if we shade in all the y values that are greater than 3, we would have a region that looks like this. Now what this means is all these xy points is a solution to this inequality. There's an infinite number of points. The points that are not shaded are not a solution and are not in the solution set. Let's do another example. Example 2. Graph y less than 1. Again, we want to think of that as an equation. Then we want to shade all y values that are less than 1. So we have our graph. We go to 1 and draw a horizontal line on the y-axis. Now the reason why this is a dotted line, this means any point that is on this dotted line is not a solution, because this is what we call a strict inequality. It's not an equal to. So all these values on this line are not a solution. If we shade in all the y values that are less than 1, we would have this area. So any xy point in this region is a solution to this inequality. Now I don't know if you noticed it, but in the previous example, when y was greater than a number, it was points above the line. For this one, when its y is less than, it's points below the line. Let's do another example. Example 3. Graph x is greater than or equal to -2. Again, we want to first think of this as an equation. This has an undefined slope. It is a vertical line at x equals -2. And then next, to do the inequality, we want to shade in the x values that's greater than -2. So we have our graph. We draw a vertical line. This is a solid vertical line because this is a greater than or equal to. If it was strictly just a greater than, this would be a dotted line. So every point on this line is a solution to the inequality. Values greater than -2, we'll think of this as a number line. Numbers to the left of -2 are less than. Numbers to the right of -2 are greater than. So the solution set would look like this. So any of these xy order pairs is a solution to this inequality. Example 4. X is less than 4. So again, we think of the inequality as an equal sign, and then we're going to shade x values that are less than 4. So here we have our graph. We go to 4 on the x-axis. Since this is a strict inequality, this is now a dotted line, and numbers that are less than 4 are to the left of 4. Example 5. Graph y is greater than 1/2 x plus 1. So here's the first example that is not a horizontal or vertical line. The procedure is essentially the same. We think of the inequality as an equal sign. Our slope is 1/2. Our y-intercept is 1. So we go to the y-axis where y is equal to 1. We put a dot and then we do our slope. Rise 1, run 1, 2, put a dot, up 1, over 1, 2, and we have our line. Next we see that the graph cuts the coordinate plane into two regions, above the line and below the line. So if we substitute in when x is 4 and solve for y, we would have y is greater than 1/2 times 4 plus 1, which would mean y is greater than 3. So these are 3 points where y is greater than 3. So thus, any point here above the line will be in the solution set. And again, when we have a greater than, it is the area above the line. To finish it, we need to change the solid line to a dotted line and then shade in our solution set. If we use the graphing calculator, we press the y equals button. Then we want to move to the left using the left arrow key and pressing enter. This will change this from a dotted diagonal line to this region. Now what this means is this is greater than, this is above the line. And hit graph, and this is what the graphing calculator will show us, which is essentially the same as doing by hand. So let's look at the process. The graph of an inequality of the form y is greater than mx plus b is a region above the line y equals mx plus b. The graph of an inequality of the form y is less than mx plus b is the region below the line y equals mx plus b. For either inequality, we use a dashed line to show that y equals mx plus b is not part of the graph. The graph of the inequality of the form y is greater than mx plus b is the line y equals mx plus b and the region above that line. The graph of the inequality of the form y is less than or equal to mx plus b is the line y equals mx plus b and the region below that line. Let's do our final example. Example 6. Sketch a graph of y is less than or equal to 3/4 x minus 1. Solution. Graph the equation y equals 3/4 x minus 1. Our y-intercept is -1. Our slope is 3/4. So we rise 3, run 4. So here we're at -1 on the y. That's our y-intercept. And then if we rise 1, 2, 3, and over 1, 2, 3, 4, we have our second point. We draw our equation. This will be a solid line because this is an equal to. And since this is a less than, it's all the points below this line. Using a graphing calculator, we hit the y equals button. We type in 3/4 x minus 1. Then using the left arrow key, we change this symbol to where it's below the line, and then we hit graph. And we have our inequality graphed. Thanks for watching.